Hello everyone! Today we are going to learn about the triangle inequality theorem. This theorem helps us to determine whether three given sides of a triangle can form a valid triangle or not. Now, since we have visually impaired students with us, we will be using various audio descriptions and tactile models to explain this theorem. To understand this theorem, we first need to know what a triangle is. A triangle is a closed figure with three sides and three angles. We have a tactile triangle with us. It has three sides and three corners, or what we call mathematically the vertices. In Euclidean geometry, triangle inequality theorem states that the sum of any two sides of a triangle is greater than the third side. If we have a triangle with sides A, B, and C, then from the triangle inequality theorem, A plus B must be greater than C. Similarly, B plus C must also be greater than A. And also A plus C must be greater than B. In other words, any side of a triangle must be shorter than the other two sides added together. Why? Well, imagine one side of a triangle is not shorter than the sum of the other two sides. Suppose the side measures 1, 3, and 5 units. If we will try to form the triangle, as we can observe, we cannot form a triangle given these measurements, since there is a gap. No matter how much you move the given sides, it will never form a triangle because of that gap. On the other hand, if a side is equal to the sum of the other two sides, say 1, 2, and 3 units, again, we don't have a triangle. Let me show you that. If we will try to connect the edges or the corner of these sticks, what we have here is simply a straight line. Now going back to the triangle inequality theorem. To demonstrate the triangle inequality theorem, we have three tactile sticks with us. Let's call them A, B, and C. Let's say that the side A is 2 units long, side B is 3 units long, and side C is 4 units long. Now let's check if these three sticks can form a valid triangle using the triangle inequality theorem. First, we take sticks A and B, add them together, which is now equal to 5 units. Now we need to check if the sum of sticks A and B is greater than stick C. We then compare the length of stick C with the sum of sticks A and B by placing them next to each other. As you can observe, we confirm that the length of stick C, which is 4 units, is shorter than the combined length of sticks A and B, which is 5 units. Next, we also need to verify if the sum of sticks B and C is greater than stick A. Adding sticks B and C and comparing its length with stick A by placing them next to each other will show that B plus C, which is equal to 7 units, is again greater than stick A, which is equal to 2 units. Similarly, A plus C, which is now equal to 6 units, is also greater than B, which is 3 units long. Since the sum of any two sticks is always greater than the length of the third stick, we can say that these three sticks can form a valid triangle. Let me show you that. And there's your triangle. And that's it. We've learned about the triangle inequality theorem and how it applies to triangles.